So, when I was a teenager growing up in Nigeria, I was not directing music videos. I did decide, however, to build an artificial intelligence. I know. I was taking computer science and logic courses at a local university, and I figured it would be easy, being a 15-year-old, to just create an AI that could reason and argue logically. I was inspired by the same dreams the early pioneers of artificial intelligence had, that we could create this supermind, an intelligence of pure logic and objectivity, and that this supermind would be free of human traits like subjectivity and bias. I was working without guidance, with really, really old computers, and with irregular electricity. If you've been to Nigeria, you might know what that's about. So let's just say I was less than successful. I did, however, go on to study in the United States and do a lot more research as an engineer on artificial intelligence. Around 2013, I was reminded of my dreams of objective AI when I heard of a Harvard professor's experiments. Latanya Sweeney at Harvard University was exploring how search engine ads change when you look up different types of names. When she looked up names more predictive of being black, she got ads for criminal justice services. So she'd look up names like Deshaun or even Latanya, and she'd get ads like, "Has Deshaun been arrested?" It's not funny, but it's kind of funny. "Do you need a bail bondsman?" When she looked up names less predictive of being black, so names like Jeffrey or Emma, not so much. Eventually, she calculated that black identifying names were 25% more likely to generate ads suggesting that the person had an arrest record, even when they did not. But these are algorithms serving up ads. Can algorithms be prejudiced? Can a piece of software be racist? Can it be sexist? Learning algorithms are recipes for teaching AI how to learn. Modern AI learns by consuming vast amounts of data. They learn by spotting hidden correlations and patterns that humans cannot see. They learn by applying neutral math equations. But the more researchers have looked, the more they've found examples of artificial intelligence systems producing significantly biased outcomes. And by bias, we mean generally violations of ethical or social norms. For example, a recent study found that search engines show more ads for higher paying jobs to men than to women. There was a recent study last year showing extensive bias in algorithms used in the criminal justice system. So, just using AI does not eliminate bias in decision-making. But how exactly do these biases get into our algorithms in the first place? Modern AI is only as good as the data on which it's trained. AI eats and processes data and uses the patterns it finds in the data to make future decisions. Now, these decisions could be as trivial as distinguishing between cats versus dogs, or they could be extremely important. An insurance company might use artificial intelligence to help it decide who is insurable versus who is not insurable. Consider the case of an artificial intelligence trying to find the best nurses. If we decide to feed this system stereotypical training data, so data consisting mostly of female nursing profiles, then chances are the system would more confidently judge future female candidates as better fits, unless it's carefully designed not to do so. The system isn't being inherently sexist. It's simply learning the biases present in our data and applying them more consistently into the future. Now, occasionally, AI develops a case of what we might call food poisoning. Back when IBM was training up the future AI Jeopardy champion, that's Watson, they had to feed Watson vast amounts of data. And then somebody decided it might be a good idea to feed Watson the Urban Dictionary. So after ingesting all that, let's just say, colorful data, Watson developed a little bit of a swearing habit. He began inserting R-rated four-letter words in his responses. Now, personally, I would have loved to watch that version of Watson on Jeopardy. But the moral here is, we need to be careful what we feed our algorithms and our AI. And the thing is, AI is not going away. AI already determines what you see on your Twitter feed, what you might want to watch on Netflix, who you might want to date. And it's going to keep making more and more of these decisions in the future because the amount of data we have and we create is vast, and it just keeps growing. Artificial intelligence and algorithms present the only viable way of making sense of this much data. So, if you want better medical diagnosis, if you want fewer car crashes, or if you want to improve the quality of human lives and prevent needless suffering more generally, you're going to need AI systems that can learn quickly, tackle complicated problems, and make or inform hard decisions. But we also want these systems to play fair. So it's great that we're beginning to get behind, or at least discard this illusion that AI, modern AI, is objective or infallible, especially now as AI is ascendant. And we can all get behind this idea that we do not want AI to make decisions that run contrary to our values. But how exactly do we teach artificial intelligence to abide by social or ethical norms? And who gets to decide what norms? Who gets to decide what is fair? To me, these are fascinating questions. And researchers have started looking at a few approaches to tackling these questions. So, first, we could disclose to consumers when AI is making decisions that affect them. Top-down government regulation may not be desirable or even feasible or effective as a way to tackling bias in algorithms. Making consumers aware is an easy first step. This also makes us more aware of the 1,000 little ways in which artificial intelligence affects our lives, and more aware of our choices as consumers of services that rely on automated decisions. Second, we could create processes for consumers to appeal automated decisions. They'd be appealing to humans, of course. Third, we could have more human oversight when artificial intelligence is making decisions in high-risk domains. This includes domains like defense or the criminal justice system. These have been policy solutions so far. There are a couple of technical fixes in the works. For example, we've been exploring ways of making AI models more transparent, more observable. Other researchers have been exploring ways of making AI models explain their decisions. The idea behind these approaches, these technical approaches, is to create a trail of breadcrumbs so that we can follow the trail of what we might call intermediate inferences forward from the inputs all the way through to the final decisions. Basically, show your work. Or we can follow the decisions, the trail backward from the decisions all the way down to underlying causes or reasons. These solutions, they help us see where AI bias exists, but they don't always fix them. And more fundamentally, they don't get to the more fundamental question of what qualifies as bias in specific domains. As an engineer, I fully own my tendency to think of or focus on technical virtuosity as the way to tackle and solve problems, just as I tried to do as a teenager all the way back then. But I'm not convinced that we can just engineer our way out of this particular problem. Because the problem is less about the technology, AI, it's more about all the social and cultural context in which we apply the technology. At the moment, we have AI being applied in fields as diverse as medicine, law, criminology, and even education. Each of these fields have different norms, different ethics. And AI is like a very smart child. It's not always clear on the context of its decisions. For example, in many states, it is perfectly legal to discriminate on the basis of demographic characteristics when you're setting auto insurance rates. Younger male drivers tend to be riskier to insure, at least so I'm told. But the ability to calibrate this kind of risk is crucial for insurance. On the other hand, it's illegal to discriminate on the basis of demographic characteristics when you're issuing mortgages. Context determines the relevant norms, and engineers cannot always teach AI how it ought to behave in every single application. We need to work closer with social scientists, so lawyers, economists, anthropologists, linguists, and I can tell you from personal experience, working across these different fields is difficult. We are trained differently, and this is not a joke, we really do speak different languages. At my day job at the RAND Corporation, we try to use, as an example, we try to use artificial intelligence models to study behaviors on social networks. This includes behaviors like radicalization, political polarization, and even cyberbullying. What you might consider fair or normative in any of those applications will depend on what you're focused on. If you're focused on radicalization, then you might not think it fair that we treat every opinion expressed on social media exactly alike. Here's the crux of the problem. We have created artificial intelligence in our own image, and this is not a compliment. AI too easily reflects human shortcomings it finds in our data streams. It amplifies our flaws. It's going to take the full range of human intelligence to correct for these shortcomings. But if we want to build better, fairer societies, we need AI systems that reflect and amplify the better parts of our nature. Thank you.